Hi everyone, welcome to our live tutorial session for today. I'm just going to wait a little bit while we have other people joining. If you're here with us now, this session is another GCSE math session on fractions, decimals and percentages, and will be led again by Molly. As most of you know, if you've joined us for sessions before, Molly is a student at Bath University, and she's done over 150 lessons with my tutor. She's also led the previous live group tutorial sessions we've had in maths this week. So if you joined us for that, then you know lots about Molly. And today we're hoping to have another really engaging session for you guys. So just before we get started, just to cover some stuff before we kick off. In terms of questions, so Molly can see the chat, so if you have anything that's urgent that you want to raise with her, then feel free to message in the chat, but with most of the questions, we'll have 15 minutes at the end to answer them like we've been doing before. I just want to say before we get started again that all of these sessions are recorded, and all of these sessions last an hour. So if you're just joining us, we have Molly, who's going to be running this session on fractions, decimals and percentages, and I'm just going to hand over to Molly now. There you go, Molly.
Cool. Hello, I'm Molly. I feel like hi guys. I feel like you all probably know me by now if you've been here before, and I just had an introduction. So we will jump straight into it. Let me just get my lesson space set up and ready. Cool. And then I can share my screen. Getting good at this now. Nice. So today we're going to do a similar format to the previous ones. I'm going to kind of do some teaching for a bit, hopefully not too boring. And then I'll go through, this time I'm going to go through quite a few exam style questions because I know that that's what a lot of you really like. And then we'll have 15 minutes for questions at the end. So let's jump straight in. So today is on fractions, decimals and percentages. So I'm going to talk a lot about, obviously we can explore loads into each specific one, but today is mostly about converting between them. And then, like I said, some exam style questions about that. So we'll start off, I'll do them in pairs. So like I'll start off with converting between fractions and percentages. So the reason that we would kind of want to, I can't see the chat. I can see that there are messages happening, but I can't actually see it. Let me just try to work that out. I do not know. Okay. Oh, I can see it. Cool. Everything's fine. Nice. So the reason that we want to do this is because fractions are easier to work with in terms of if you have to multiply them, divide them, stuff like that. Whereas percentages kind of make more sense to us. They're more intuitive. So, you know, if somebody said, oh, this is an 8th off, you know, that sounds a bit weird. Whereas 12.5% is something that we can work with a bit better. So that's kind of why. And basically, this one is nice and easy because a percentage is just a fraction out of 100. So if we have something like 1/2, we just want to write that as something out of 100. So 50 out of 100, and then it's 50%. We'll go over some harder ones as well, but that's all it is. So if you want to get from a fraction to a percentage, you just times it by 100. So I'll do another example for you. And I'll show you a couple of ways to do it. So let's say we have 12 over 25. Now, like I said, the reason that we would want to convert this is because 12 over 25 doesn't really mean much to us, if that makes sense. It will make a lot more sense when it's as a percentage. So there are two ways that you can do this. Oh my gosh, sorry about these notifications. You can either, if you can immediately see how to make the bottom bit go over 100, you can do that. So we can see that 25, we have to multiply it by 4 to go into 100. And 12, we therefore multiply by 4. And then just as before, this is our percentage. Ta-da. The other way that you can do it, if you maybe can't see what the bottom bit goes into, is just times it by 100. So I'll write this in a different color. 12 over 25. So this first method is a lot easier if you can spot it. This second one you can apply to any fraction, if that makes sense. So if we had something, say, over 30, you don't really know necessarily, there's no whole number that you can multiply that by to make 100. So whilst this second method, the maths, the actual multiplication and stuff is a little bit harder, it's a method that you can use every time. So we'll times it by 100, which is like timesing it by 100 over 1. So we get 1,200 over 25. And then if you simplify that down, you will see that that is also going to give you 48. And then you just whack a percentage sign on the end. So these two methods are exactly the same thing. The nice simple method, just make it something out of 100. We can then go the other way. So let's say we have a percentage. Let's say we've got a horrible one, 16.4%. And we want to make this into a fraction. So what we do here is we essentially divide it by 100. So you do the opposite. And what we do is we're going to work with how we simplify fractions to do that. So we just write 16.4 over 100. Now this is kind of an answer, but we obviously want it in a nicer way. We don't want decimals on the top of our fraction. That's horrible. We want nice fractions. So we start off by getting rid of that decimal by multiplying the top and the bottom by 10. So we get 164 over 1,000. Now this is much nicer. It's just a whole number over a whole number. So we know what we're looking at. We know that it makes sense. Some people says, okay, I think the audio is fine. So we want to simplify this. So the way that we do this, you can either maybe see immediately that we can divide both of these by 4, or if you can't, I always do it in like loads of steps. We start off by dividing by 2. So whenever you're simplifying fractions, you do something to the top and something to the bottom. So here we see that 2 goes into the top and the bottom. So we get 82 over 500. And then, oh my gosh, we can divide those by 2 as well. So we get 41 over 250. So that's how, so 16.4% is the same as 41 over 250. And obviously 16.4% makes more sense to us. We can imagine 16.4% of a cake. We can't really imagine, or maybe you can. I can't imagine 41 250ths of a cake. However, the fraction is a lot nicer to work with than this horrible decimally percentage. So that's why and how we do that. So hopefully all of that makes sense. Just checking nothing in the chat. Cool. So now we'll go on to fractions and decimals and converting between those. Do let me know if I'm going too fast or anything. So fractions and decimals. Now these are probably the ones that you are most familiar with, especially in terms of converting between them. So again, decimals can be easier to understand, fractions can be easier to work with. So a decimal is kind of just a bit like a percentage. For example, if you have 0.34, that's 34%. So a decimal is something out of 1, a fraction is something out of 100. So they're really, really similar. So we're going to use fairly similar methods, at least to think about them. So this is the hardest one to do, but it is also the most useful, and you will get to grips with it a lot more. So let's just do some examples. So decimals to fractions is the easier one. So let's say we have 4.56 and we want to make this a fraction. So obviously immediately this looks horrible, right? But we're going to do something really similar to what we did before. Make it into some fraction, no matter how horrible, and then use what we know about fractions and simplifying them to make it something a lot nicer. So the first step that we're going to do is just write this as something over 1. It sounds ridiculous, but what we've done now is kind of made a fraction just by putting it over 1. And now we can work with this to make it a nicer fraction. So we will times it by 100 to get rid of this decimal point. Because there are 2 numbers here after the decimal point, times it by 100 will make it 456. I hope that makes sense. So we have 456 over 100. And now, hopefully you can see that we can divide both of these numbers by 2. So we'll get 228 mental maths, over 50. And then we can divide these by 2 again and get 114 over 25. And that can't be simplified any further. So we've seen that 4.56 is equal to 114 over 25, which sounds really complicated. Like, how the heck did we get between those? But it only really took us these 3 steps. So the key thing is just to write it over 1 and then just kind of work with it and see what you get. So yeah, people were putting it in, cool. Awesome. Okie doke. We'll have a go now going the other way. So fractions to decimals. This one's a bit harder, but it's pretty cool. It's all right. So to do this, we're going to use the bus stop method, everybody's favorite. And I will show you how. Basically, if you are comfortable with the bus stop method, you can convert these, no problem. There's just a tiny little trick with it. So let's say we want to write 17 over 40 as a decimal. We're basically going to do exactly that. So this is essentially saying 17 divided by 40. So that's what we're going to do. We're going to do 17 divided by 40. Now, you'll notice a couple of things here. 40 doesn't go into 1. We carry the 1. 40 doesn't go into 17. Okay, it's 0. We kind of knew that. 40 doesn't go into 17 any whole number of times. So what we're going to do is make this 17.0000, however many we need. We can extend this. And now we carry this 17 and make sure that the decimal point goes in the same place that it is down here. And now it's 40s into 117. Hopefully that makes sense. We're just carrying it along.
We do have a question, Molly.
Oh, yeah.
Someone's asked, why didn't you change that fraction into a mixed fraction?
Okay. Just go back up to this. Because I didn't want to. You can. It completely depends on what the question asks you for. I'll change it into a mixed fraction if you want to. So just in case anybody's doing it, wants to check their answer. So 25 goes into 114 4 times. And then we have the 14 left over. So it's 4 and 14 25ths. And to be honest, yeah, a mixed fraction actually makes a lot more sense to us. We know that this looks like a bit like kind of 4.5-ish. So you're right. And we can see that's what that is. I just prefer top-heavy fractions because you can work with them better. So that's the reason I didn't, was because I didn't want to. It completely depends on whether the question asks you or not. Cool. So back to this one. Yeah. Now we're looking at 40s into 170, and I can see a couple of people have got it on the chat already, which is amazing. So this is going to go 4 times because that makes 160, and then we have 10 left over. So then it's 40s into 100, which is 2, with 20 left over. And then it's 40s into 200, which goes 5 times, with nothing left over. And as soon as we've got nothing left over, we're done. We don't need to use the rest of these zeros. We don't care about them anymore. What we've got now is this. So 0.425. So 17 over 40 is equal to 0.425. Someone said, I'm so smart. Yes, you are. If you got that, well done. Woo! Hopefully that makes sense. It's just the bus stop method, but add extra zeros after a decimal point. We'll do one more, just because I think this is the hardest conversion between any of them. So let's do 11 over 8. So we're going to do 11 divided by 8. And we know that this is going to be horrible, so we're doing 0.00000. Cool. So 8s into 1, don't go. Carry this 1 over. 8s into 11, go once. And then we have 3 left over. And remember, it's really important where that decimal point goes. Now it's 8s into 30, which goes 3 times with the remainder of 6. 8s into 60 goes 7 times, up to 56. I hope I'm going at the right pace, by the way. Do shout if I'm not. Goes 7 times with a remainder of 4. And then 8s into 40 goes 5 times with no remainder. Woo, no remainder means we don't care about the rest of the zeros, and we've got our solution, 1.375. Just check the chat, check that people got it. Can you go slower? Yes, of course I can. Sorry. Someone said, isn't it easier doing it the long division method? It depends on what you prefer. I personally think that this one is easier, but it's completely up to you. I'm not going to go over the long division method because I don't use it enough to be good at teaching it. But yeah, cool. Just shout if anybody wants me to go over another one of those. I'm more than happy to, because I know that it's quite a confusing one. So, in fact, I can put the chat at the side and then I can see, oh, I'm a genius. Right, now we'll go over the last conversion, which is decimals and percentages. To be honest, like I said, oh, can you do another one of those questions? Yes, I can. Cool. Let me make something up. Oh gosh, there's a lot of pressure now to make something that's gonna be nice. I'm gonna do it the other way around. I'm gonna do 5 over 41. I have no idea if this is going to work. This could end up being a recurring decimal, and you'll see what that's like. But we'll give it a go. So I'll try to do it a bit slower as well. So this fraction means 5 divided by 41. So that's what we're going to do in our usual bus stop method. 5 divided by 41. And because we can see that 41 isn't going to go into 5 any times, we're going to put on all of these zeros. We don't know if we're going to use them all, but we might use a couple of them to work out the decimals. I'll try using some colours as well. Maybe that will make it a bit better. So 41s into 5 go 0 times with a remainder of 5. And we've got to remember to put the decimal point in the same place above, in line. So then it's 41s into 50, which hopefully you can see just goes the 1 time, and then we have the remainder of 9. So we put the 1 here, and there's a remainder of 9. So now we're looking here at 41s into 90, which you can see goes in twice. So 2 lots of 41 gets us up to 82. So it goes twice, and then gives us a remainder of 8. So we'll put that in. So now it's 41s into 80. I've got a horrible feeling that this is going to be a recurring number. I'm just going to check it. Someone's probably already checked it and told me that I'm doing a silly example. Yeah, okay. Because this is going to be a horrible one, we're just going to go up to 4 decimal places. And then I'll do one that I know works. Someone's probably shouting that in the chat. Yeah, cool. So people are doing it to varying levels. So 41s into 80 is just going to go 1 time. And then we have this horrible remainder of, 39. So now it's 41s into 390 and so on. But this is the first 3 digits of that. Hopefully that makes sense. Let's do that. Yeah. Does anybody want me to do another one? Someone very definitely doesn't. Okay, cool. I'll go on to, I can always come back at the end. Cool, so I'll go on to converting between decimals and percentages. Cool. Decimals and percentages. As I was saying before, you don't really need these to like knowing the exact way to convert, because if we can go from decimals to fractions and then fractions to percentages and vice versa, then we're fine. but we may as well look it away because it's not too bad. It's fairly nice and easy. This one is super useful when you're doing percentage questions. So if you're saying what is like 40% of something, it's much easier to see that 40% is 0.4 and times it by 0.4. I'll do a thing, and then give you an example. It'll make sense. So let's jump straight in with an example of, say, 48.1%. Now, all you do is we're essentially dividing by 100. We're just going to move this decimal point 2 places to the left. Just pop it down, 1, 2. So we end up, and get rid of that percentage sign, so we end up with 0.481. Hopefully that makes sense. And the reason that this is useful is, say the question said, what is, I'll write it out actually, what is 48.1% of 250? That looks horrible, and it's like, what? Because sometimes when we do percentages, we work out what 10% is, therefore work out what 40 is, and so on. You might have done it that method. A much nicer thing is that the word of always means times. So this is really helpful. So we can convert that that percentage into a decimal, like we just did. So we know that's 0.481, just hopping that decimal point down 2 places left. And then of means times 250. And then suddenly, instead of a horrible percentages question, you've actually got a really easy for your calculator, multiplication. So then you can work this out. 250 times 0.481, 120.25. And you can see that looks right, because 48.1% is about 50%, and that's about 50% of 250. But that's a really nice way. Why is it 250? That was just an example that I did. That's just what the question could have been, was like out of 250. Yes, I essentially did divide by 100. So yeah, cool. Okie doke, I'll do an example going the other direction. The other direction is, shock horror, you move the decimal point 2 places to the right. So say we have 0.772. Let's make it horrible, 0.7723. What a horrible number. All we do is take this decimal point and hop it 1, 2 places to the right, and whack a percentage sign on the end. So it's 77.23%. That one's really nice and easy. We like decimals and percentages. So good, we can do it really nicely. So hopefully all of that makes sense. And now we can spend 15 minutes or so going over exam questions, and then 15 minutes at the end going over if anyone has any specific questions. So let me grab a look at this preparation, right? And then we can pop this on here. Lovely. So I think that these are all, I'm not sure if they're past paper questions, but they're exam style questions. So whatever exam board you're on, these will be quite applicable. So let's have a look. There are 60 beads in a bag. The beads are red, yellow, or blue. 40% of the beads are blue. 5/12 of the beads are red. How many beads are yellow? So there are a couple of ways that we can do this question. We could make them both percentages. We could make them both fractions. We could make them both decimals. Whatever way we want to do it. Yeah, it just depends on whatever's easiest for you, really. I would say probably, if looking at 5/12, that's probably not going to give us the nicest amount. The other thing that we can do is work out how many each of those things are. So that's the way that I'm going to do it now. So work out how many beads are red, how many beads are blue. So let's start with the blue ones. So this is actually really similar to the thing that I just did. If we just write out what we want, so 40% of the 60 beads. Now, hopefully, if you are listening to the last one, you'll see that we can just make this into a decimal. So we remember that the decimal point is kind of like here, and we hop it 2 places to the left. So this just becomes 0.4 of means times 60. And then we just have to do 0.4 times 60. And let's say that this is on a non-calculator paper. The way that we can do something like 0.4 times 60 is either then make this decimal into a fraction, or see that 0.1 times 60 is a tenth of 60. That's kind of making it a fraction anyway. Basically, what I'm saying is that this is like 4/10 of 60, and then 1/10 is 6. So we times that by 4 and we get 24 of them are blue. Does anybody not get that? Ooh, wrong tab. Oh my gosh. Just trying to get the chat up. Got it? Cool. Oh gosh, people are way ahead of me. People are really getting these numbers quickly. Nice. Someone asked, is this foundation or higher? I think this could be either. This could either be a harder question on a foundation paper or one of the earlier ones on a higher. Yes, we're stopping for questions in the last 15 minutes. So there are 24 blue beads, and then red is 5/12 of 60, which we can spot as exactly the same thing. It's 5/12 times 60. So if it's calculator, you can just put that in. Or we can see that 1/12 of 60 is 60 divided by 12, which is 5. And there are 5 of them, 5 of these 12ths. So there are 25 red. And then, yeah, as a lot of you pointed out, we then have that the total of the blue and the red is going to be 49. So there are 11 yellow. Well done. A lot of you got that really quickly, which is fantastic. Again, someone said, what level is this? I would say that this is around a level 5 or 6. 5 question? I'm not 100% sure, sorry. I think it's around that. Let's have a look. Yeah, let's do this one. So, in the sale, jumpers are on the offer, buy 2, save 1/3 of the price. Jeans are also currently 30% off. Jumpers are £45 each, jeans cost £50. What is the cost of buying 2 jumpers and 2 pairs of jeans? So again, this could be foundation or higher, I think. So let's have a look. Let's start with jumpers, because that's the first one that's on here. So jumpers are buy 2, save 1/3 of the price. And that's exactly how many we want, jumpers. So first of all, 2 jumpers is going to cost us £90, 45 times 2. And then we want to save 1/3 of the price. So we want to know what 1/3 of 90 is. Now this is just the same as doing 90 divided by 3. So it's £30. But remember, this is how much we save, not how much they cost. So it's important to do 90 minus that 30, because that's how much we save, that's how much we're taking off. So that gives us £60. So that's how much the jumpers are. Now we can look at the jeans. So the 2 pair of jeans would cost us £100 because they're £50 each, and we're buying 2 of them. Now we can see here, jeans are 30% off. So there's a couple of ways that we could do this. People have probably already started saying chat. Yeah, nice. Cool. So we can either, I'm going to write this in 2 different colours for 2 different ways. We can either see that 10% is £10. Whenever you're doing 10% of something, it's just dividing it by 10, right? Because 10 out of 100 is just dividing it by 10. So then we can see that 30% is £30. So you're saving £30, so the cost is £70. Or you can say we can do a little bit of conversion. So we can convert this to a decimal. So 30% as a decimal is 0.3. I guess there's kind of 3 ways that we can do this. And then we can do 0.3 times 100, which also gives us 30. So we know that it's then 70. Or we can save that kind of subtraction step and just say, well, if they're 30% off, then we're paying 70% of the price. So we can straight away do 0.7 times 100 to get us the answer immediately in just one step of £70. So then, as people have quite rightly said, the total is 60 plus 70, which is £130. Let me just check the chat to see that that made sense. Yes, cool. A lot of people got it. Really good job. Nice. Hopefully all of those methods of doing the percentage that I said made sense. You don't have to understand all of them, just one that works for you. This one is a really good one to be able to do because it means that if it's something like 12.7% off, that's going to be quite difficult to do in this way. So it's nice on a calculator paper to be able to convert it to a decimal and multiply. Can we do a harder question? Yes, we can. Let's scroll right down. Oh gosh. Oh, there's the solutions. Don't look at those. Let me see. Okay, cool. Let's do this one. There are also a lot of quite difficult questions that I could do just in terms of percentages. We won't have time to do it today because that's not what this session is about. But as always, you can always give feedback. Oh, how many marks would you get for that question? That one there, I'm not sure. Does it actually say it on here? No. Let me have a look. That would probably be a 3-mark question, maybe a little bit more. You'd get at least 1 mark for this, 1 mark for this, and 1 mark for the total. So this question, however, would be quite a few marks. So let's have a look at it. At Redbridge School, 1/3 of the pupils have a dog, 2/5 have a cat, and 1/15 have a hamster. The rest have no pets. So let's just start with part A. What fraction of the children have no pet? We want to write this in its simplest form. So hopefully you can see that the way that we're going to do this is add up those fractions and see what's left to take us up to 1. Because the rest have no pet and all the fractions have to add up to 1, because 1 is like our equivalent of 100% of the students. So we want to do 1/3 plus 2/5 plus 1/15. So we're going to put them all over a common denominator. So to make 3, 5 and 15, first of all go into 15. So let's put them over that. So to make 3 into 15, we times it by 5. So that's what we'll times the 1 by. To make 5 into 15, we times it by 3. So that's what we'll times the 2 by. And then 1 over 15, because I already like that. And then we just add up these top numbers here. So that's 12 over 15. Hopefully that wasn't too quick. Yeah, well done, 3/15. Perfect, someone said that that is equal to 1/5, well done. So 3/15 have no pet, and then we can simplify this fraction, dividing the top and the bottom by 3. So 1/5 of them have no pet. Cool. So let's have a look at part B. There are 250 pupils. How many children have no pets? So we've just worked out that it's 1/5. So it's 1/5 of 250. So remember, there are a couple of ways that you can do this. You can either immediately see that for that, you have to divide 250 by 5. Or we can just put it into our calculator if this is a calculator exam and say 1/5, because of always means times, 1/5 times 250, which will give you 5. Or if we want to, if we don't like putting fractions into our calculator, we can make this a decimal and say that 0.5 is equal to, 1/5 is equal to 0.2 and times that by 250. I'd say that this one is the nicest because you can also do this without a calculator. So then we get our answer of 50 students. Okay, cool. So part C, this is the hardest part of this. I might have to do it on a new page because I'm running out of room there. So I'll just note the answers here so that we can refer back to them. A was 1/5, B is 50. So now let's have a look at part C. How are we doing for time? Okay, nice. Some questions. Perfect, cool. So at the Bluebell School, 23% have no pets. What percentage increase of pupils at the Bluebell School have no pets compared to Redbridge School? So this is a really difficult question. So, you know, we've had some nice questions, we've done some fractions, some multiplication, and now suddenly they're talking about percentage increases. That's not nice. But it's okay. It's not too bad. We can work this out. So, lucky for me, they've called it Bluebell and Redbridge, which lends itself wonderfully to colour coding. So, Bluebell School we know is 23% have no pets. So it would be sensible to now work out what percentage of pupils at Redbridge School have no pets. So we know that it's 50 of their 250 pupils, or we can say 1/5. So we can take either of those questions and see these are the same thing. Now the nicest way to make this into a percentage, if you remember, is to put it as something over 100. So if we put this something over 100, see if anybody's, yeah, brilliant. This we have to times it by 20, so we times the 1 by 20, so it's the same as 20 over 100, which means that it's 20%. So I'm pretty sure the answer wants you to say that that's 3% more. I'm just going to check that actually, because sometimes they're a bit worried about that. Yeah, 3% more, there we go. Yeah, and as some of you correctly pointed out, that's 3% more. And that's often why we really like percentages, because we can compare them quite nicely. We can think about them as, you know, we're more familiar with percentages, so we can compare them directly and make it nicer like that. Let me just check the chat. Okay, cool. So I know it's a couple of minutes before 1:45, but there's not quite enough time for me to do a whole question. So yeah, does anybody have any specific questions that they want to ask?
Hi, Molly. So I haven't actually seen any exact specific questions come through. I think people are getting all the content and answering the questions correctly. Maybe then you do have some time to go through another full question, and then if
Sure.
any pop up in the meantime, then I'll let you know.
Okay, perfect. Cool. Yeah, someone's just said, where do you find all your questions from? These ones are from I think from the TES website. A lot of them have free resources that you can download. Another one is called Maths Made Easy. All of these you can access just like I can. MME, which have some great questions. Basically, if you just type in GCSE Maths, whatever the topic is, questions, you'll get loads of links and resources. Someone said, when should you simplify? Whenever you can, really. If they ask you for like a fraction, you should generally give it in its simplest form. Yeah, it makes it easier to work with for you as well if you simplify things. And I'm going to go over the questions now that I haven't covered, because I think we've got some time to. So there's a couple here, so we'll just try to go over them both. So we'll start with this one. Cool. So, gosh, long question. Family discount card offers deals for the cinema. The card states, so 45% off all adult tickets, and children save 2/5 off of full price tickets. I don't know what kind of cinema is making you do the maths like this, but a horrible one. So the cost of an adult ticket is £10, and a child's ticket is £6. So the first thing that we want to know is how much it will cost to buy 2 adult tickets and 3 children's tickets. So let's have a look at A first of all. So the best way to do this is to do it in 2 separate chunks. So 2 adults tickets and then do 3 children's tickets and add them together. So 2 adult tickets. Well, we'll work out what that would normally cost. £20, right? 2 of those £10 tickets. And 45% off all adult tickets. So we want 45% off £20. So now, if we want to do this, we'll do it in the nicest way, which is just doing one decimal multiplication. So we'll pretend that this is a calculator paper. So we'll do that. So if it's 45% off, how much of the price is it? Does that make sense? Do you know? No one says, I'll just say I might have worded my question badly. Oh, someone's made a good point. Shouldn't it be 45% off each individual ticket? That will give us the same thing, basically, because we're multiplying, and it doesn't matter whether you multiply and then add them together or add them and then multiply. So basically, yeah, 45% off 20 is the same as 45% off 10 plus 45% off 10. That's a really good question, though. Basically, what I was looking for was that it's going to be 55% of the £20 of the price, right? If it's 45% off, it's the other 55% that you're paying. So then we can convert this to a decimal, 0.55, and then of the price, which is 20. So then we can put 0.55 into our calculators, which will give us, I hope it gives us £11 anyway. Yeah, it should do. So that's how much it is in total for the 2 adult tickets. I just think that that's a nicer way to do it, because these steps you can all kind of do in your head and just straight away so that it's 0.55 times 20. I hope that made sense. How did you find 55%? Sorry, I should have explained that better. 100 minus 45, basically. Let me explain it with some different examples. So if we have 30% off something equals we're paying 70% of the price. They add up to make 100. If we have 15% off something, we're paying 85% of the price. These numbers add up to make 100%. Don't worry if you don't get it this way. You can always do it and then subtract. Does that make sense now? Okay, cool. Yes, okay, cool. I'll finish this question and then do the other one from there. Brilliant. Okay, nice. Someone said, wouldn't the 45% be 9? Yes, it would. That's what we're then taking off. So 20 minus 9 is the same as 11. So the amount that you're saving, so the price minus the amount that you're saving is the same as what we've just worked out, the price that you're paying. Hopefully that makes sense. Cool. And then we'll look at the 3 children's tickets part. So 3 children's tickets. Well, what would that be? 6 times 3 is £18, and they're saving 2/5. And that means, in a really similar way, our fractions adding up, they're paying 3/5 of the price. So we could work out 2/5 and subtract it from 18, or we could just straight away work out 3/5. Does that make sense? Because that's adding up to our 1. So we want to do, well, let me do this in a different color to make it a bit clearer. We want to do 3/5 of 18, which is the same as times 18. And that should give you, well, I'll show you how I do this. 3/5 times 18 is the same as 3/5 times 18 over 1. So we get, sorry, just this. So we get 3 times 18, which is 54 over 5. Now this obviously isn't the nicest. We kind of want this more like a decimal. So we can do some conversion. Crazy. So that's what we'll do here. 54, let me do this in a different color again. 54 divided by 5. Put all of these decimals on here. So 5s into 5 go 1. 5s into 4 go 0 times. Remember to put the decimal place. Remainder 4. 5s into 40 go 8. And then we don't need any more of these decimal places. This is our solution. So this will be £10.80. is how much it costs. £10.80 for the kids. So we're going to add those costs together, 11 and £10.80, and we'll get £21.80, which I think a lot of you got really quick, which is brilliant. Why is it 3/5, not 2/5? So again, this is it's similar to what I was saying before. So we're doing 2/5 off, which is the same thing as 3/5 of the price. So I'll show you what I mean. We could have done 2/5 of £18, which is £7.20. I won't do the division again to show you that. So that's how much they're saving. And then you do 18 minus £7.20, which gives you that £10.80. So we could have done that. But we know that that £10.80 has to be the remaining 3/5. And that's because 2/5 and 3/5 make one. So that's the remaining bit. So hopefully that makes sense. Basically, I'm just being lazy and not doing the subtraction. You can basically do a little bit more thinking to mean that you get to be lazy and not do the subtraction, which I think is always a win. Cool. So hopefully that one makes sense. Can you go back to the, wait, let me zoom out anymore. What did you want to see, this or that, or this? Is that what you wanted to see? On there, hopefully. Okay, I think that was anyway. Yes, awesome, cool. So what I'll do now is I'll just go over the last question that was on that sheet. I know that there's some people were asking for slightly harder questions. Hopefully this, oh, in fact, sorry, there's one more question on this, isn't there? So we'll do that one first, which I think might be a bit harder. So let's have a look at this one. And then hopefully we'll have time to do that final question as well. So part B, the cost of a family discount card is £40 per year. How many times in the same year would 2 adults and 3 children need to go before they start to save money on the cost of the card? So I think this is a really difficult question. This is probably a level 7+ question. So hopefully this, again, if you're doing foundation, don't worry if you switch off here, but try, because I think hopefully I can explain it in an accessible way. So what we're going to do here is use this hint which says find the cost of the tickets without the discount card. So that's what we'll do. So without the discount card, we still get this discount. So it's what we said. The cost of these tickets is £21.80, because the first question was 2 adults and 3 children. So we know that it's 21. Oh, in fact, let's draw a nice little grid. Look at this. So we'll say with the discount card, without the discount card. And we'll look here at the number of trips. 1, 2, 3. We might need to go further, but we'll see. So with the discount card, however many trips you do, it's always going to be £40, right? We've just paid that per year. We've paid £40 for the whole time. So we could go 100 times into the year and it would still cost us £40. Without the discount card, it costs us £21.80 each time. So £21.80. The next time, it's going to cost us £21.80 as well, but added to that, so overall for those 2 trips, it's cost us £43.60. And then if we were to go a third time, it would cost us another £21.80. So it would cost us £65.40. Does that make sense? I hope it does. So then we can see that even if we just go twice, it's cheaper to buy the family card, because without the discount card, it would cost us £43.80. Whereas with the discount card, it still only cost us that flat rate of £40. Someone said yes. Someone said, can you slow down? Yes, for the next one, I'll go a lot. Well, I'll try to go slower. I only have 5 minutes though. Cool. I
think we can maybe carry on for maybe another 7 minutes or 10 minutes, because I know we started a little bit late.
Oh, that's true. Yeah, sure thing. That's fine. We should have a chance to do this final question then at a nice slow pace. Cool. So, okay. This is a nice question. We've got percentages, decimals, and fractions. It's like Christmas. Right, so £54 of inheritance money is split between Abby, Babs, and Kaz, ABC, as we'll call them, in the ratio 1:3:2. So we've got a bit of ratios in here as well. Abby gives 80% of her money to charity. Babs gives 0.25 of her money to the same charity. And Kaz also gives 2/9 of her money to the charity. So we want to know how much money in total the girls donate to charity. So hopefully the question makes sense. We basically, first of all, want to work out these ratios. Now, ratios could be a whole other topic. But just to quickly say, ratios are just fractions in disguise. So if we've got something in the ratio 1:3:2, imagine splitting something into chunks. We've essentially split it into 6 chunks because we've got a chunk of 1, a chunk of 2, and a chunk of 3. So we just want to know how much each chunk is worth. And well, if we split £54 into 6 chunks, each chunk is worth £9. I know I'm going over the ratio part quite quickly, but that's because I want to more get onto the fractions, decimals, and percentages bit. So this means that Abby gets 1 of those chunks. Babs gets 3 of those chunks. And Kaz gets 2 of those chunks. So we've worked out using the ratios, which, like I said, they're just fractions in disguise, because it's really just saying that Abby gets 1/6 of it. And Babs gets 3/6 and Kaz gets 2/6. Hopefully that makes sense. What's the difference between a ratio and proportion? Oh my gosh, that's a very good question. I feel like they're kind of similar words for the same thing. Yeah, ratio is kind of like this, whereas a proportion is more like a fraction. So you could have a proportion of 3/8 of something. They all kind of mean the same thing. They're just ways of expressing how much of something we have. So now we have the amount that they each have, we've just got to work it out. So Abby gives 80%. Let me do these in colours. Big fan of colours. So 80% of £9. Well, we're going to do it my favourite way, which is make this a decimal, 0.8. We've just imagined that there's a decimal point here and moved it 2 places to the left. Of is times, and then and £9. 0.8 times 9, which is going to give us £7.20. So 7.2. Cool. Then we'll look at how much Babs gives. So 0.25 of her money. Well, luckily, but it's already been made into a decimal for us. So 0.25 of her money, right? So 0.25 was what we've been given. We've just written of as times, and then we've worked out how much she has. So it's 0.25 times 27. I'm imagining, by the way, that this would be calculator and you're putting these all in. If not, it's just some like mental maths work. Or and this will give you £6.75. I'm going to work it out so that I don't make an error. Yeah, £6.75. And then finally, I'm just going to, hopefully that ratio bit is fine because I'm just going to move that off the screen. And then Kaz gives 2/9. So it's 2/9 of the money. So Kaz's money is 18. And here we're going to do this in the way 18 over 1, remember, when we multiply fractions. So this becomes 36 over 9, which is just 4. And now we've got the 3 amounts that are given to charity. And we can add these all together, which I'm going to use my calculator for. £7.20 plus £6.75 plus 4, £17.95. So really well done if you got that. That's used everything that we've learnt today, really. Some conversions, some percentages, decimals, and fractions.
Great. Awesome. I think that might be a good place to start to wrap up, seeing as that's covered everything that we learnt today. Just a few little things from me. Quite a few people have said they found this session really great and have asked whether we're going to have some more science sessions as well. So yes, we do have plans for more science sessions. I know we had a physics one yesterday, which lots of you might have tuned into as well, but we're going to be having some biology, chemistry, physics and math sessions all next week as well. So look out for an email about those. And I've just seen a question come through saying, are we going to be having a geography one? Hopefully we'll be expanding a lot into a lot more subjects very soon. So stay tuned, guys, and thanks again for joining us. We hope you had a really good session today, and look forward to seeing you all next week. Bye.
Bye.